Okay, good afternoon again, class. Proceed tayo sa chapter, second to the last chapter nung aaralin natin. Okay, so recap lang nung last time. Ano ba ginawa natin last time? So yung last time, nagano tayo, second order circuits. Tapos ang haba nung chapter na yun, di ba? Kasi merong undriven RLC, tapos driven, ang haba-haba ng mga solution. Okay? Ayan, haba niya. So ngayon, punta tayo dun sa impedance na tinatawag natin. Okay? Hindi ko familiar na kayo sa impedance pero let's take a slow discussion. Okay? So, ayan. Balik ulit tayo sa usual method. Tulad nga nung sinabi ko last meeting dun sa nag-solve tayo ng problem set number 7. Ito yung usual method. Okay? So, yung circuit model ng problem, drawing mo, simplify mo as much as possible, kuha ka ng Thevenin, pagsamasamahin mo yung mga resistor, pagsamasamahin mo yung capacitor, etc. Okay? So, una mo gagawin, simplify the circuit. Next is to formulate the differential equations ng mga makikita mo doon kasi may capacitor ka na and inductors. Tapos, solve mo yun. Meron kang homogeneous, meron kang particular. Okay? So, yung equations naman natin linear. So, huwag nyo na problemahin itong pangatlong statement yan. Kapag hindi linear or non-linear siya, numerical methods yung kailangan mo. Okay, paano magiging non-linear? Kunyari, yung meron kang term na ganito. Yung naka-square sila, ganyan. So, yan. Problem yan. Okay? So, mahirap siya i-solve by hand. So, kailangan mo ng computers to solve for it. Oops, sorry. Okay? And then, kapag na-solve mo na si homogeneous, then particular, babasahin mo ulit yung problem. Titingnan mo kung may initial condition. Tapos, ayun, plug in mo yung mga initial condition para makuha mo yung constants doon sa homogeneous part ng solution mo. Okay? So, ayun. Tapos, ayun yung solution. Ayun yung total mo. Ayun yung total solutions. Tapos number 5 kung may kailangan kang other voltages or currents doon sa circuit mo. So kailangan mo pa rin solve yun. Pero ano na lang naman yun, Ohm's law na lang naman yun. Or di kaya KVL. Okay? Okay. So yung usual method, mahirap siya math. Mahirap yung math. Nakakapagod siya. So let's try to look at things kung paano mapapadali yung buhay natin. Okay? So kunyari balikan natin tong isang example natin. So RC circuit, first order circuit lang ito, tapos ang input mo is a sinusoidal, okay? Cosine omega I. Okay? Omega 1 pala, omega 1. Okay, cosine omega 1. So, syempre, as usual, ito na yung simplified circuit mo. Number 1, okay ka na doon. Number 2, kailangan mong kunin yung differential equation governing this. Okay, mag-KVL ka lang. So, negative VI plus VR plus VC. Okay. So, sulat natin. KVL ka, negative VI plus, magka-clockwise motion ako, no? VR plus VC. Then, everything must be equal to 0. Lipat na lang natin yung input dun sa dulo. So, VR plus VC equal VI. Tapos, VR is just the current through it times R. IC times R plus VC. VI. Bakit VC? Ba't IC yung current na dumadaloy sa kanya? Kasi naka-series to. So, isang current lang yung dumadaloy. And alam natin na yung current na dumadaloy doon is related to the capacitor, which is IC. Okay? Okay. So, IC, ano yung state equation niya? Diba? C, dVC over dt times yung R plus VC plus equals VI. Okay. So, ito yung differential equation natin. Okay? So, yung homogeneous part, homogeneous VI is equal to 0. Ipo-force mo yung input mo to be 0. Okay? So, that's your homogeneous part. Okay. Terminologies lang. Yung tawag pala sa ganitong input. Tawag sa kanya ay tone burst. Okay? Kasi, kaya siya burst kasi at t greater than or equal to 0. Saka siya lumalabas. Nagbo-burst yung tone. Okay? Okay, wala lang. Terminologies na. Okay. So, yung homogeneous part na equation, tinatawag tong terminologies lang ulit. Natural response. Okay? Okay. So, solve natin yung homogeneous part. Alam na natin yung solution dito. So, VCH is equal to A e raised to negative t over RC. Okay. So, yan. Solve na natin yung homogeneous. Walang ka-problema. Okay. VCP. Ito may problema tayo kasi yung VI natin is a cosine. Okay, yung particular ay may tinatawag naman natin siyang terminologies lang din. Forced response. Okay? So yung VCP natin, manghuhula tayo, bibigay tayong ansatz. And yung wise guess natin would be, syempre, in the form of sinusoidal din. Let's just say na this is a combination of sines and cosines. So B cosine omega 1t plus B sine omega 1. Okay? Okay. And then, pwede kong pagsamahin pa to. Pwede natin pagsamahin yung mga cosines and sines by trigonometric identities. So, I could just write them as a single cosine, omega 1, t, plus some phase factor. Okay? Kung gagawin ko yung simplification na yan, pwede akong pumunta sa ganito para cosine na lang. No? Okay. However, problema dito. Pag tumuloy tayo sa pag-plug in nito sa differential equation natin, ang problema ay mahirap siya i-manipulate. Okay? So, magkakaroon ka ng cosine sa left-hand side, tapos dito cosine, tapos sine, tapos paano mo i-combine? So, i-combine mo na naman, magkakaroon naman ng phase factor. Okay? So, hassle siya gawin. So, now let's take a detour, no? Para ma-solve tong problem na to. Let's take a detour. Okay? Ngayon, mag-assume tayo ng pecking drive. Okay? So, papalitan natin yung input natin. By this equation. Okay? So, imbis na VI cosine omega 1t, ito, VI cosine omega 1t, palitan natin siya ng ganito. So, ibig sabihin nung may ganun, no? Ibig sabihin, peke itong drive na ginagamit natin. Not the actual drive. Okay. Tapos, si S1 is just, S1 is just J omega 1. Okay? Okay. So, itong sa exponential na imaginary yung S, pwede natin siya isulat as ganito. Okay? May useful yan mamaya. So, may bago tayong particular solution, no? Siyempre, yung homogeneous parehas lang. VCH is equal to VCH. Okay, parehas lang, di ba? Kasi is zero out mo pa rin naman yung source mo pag kukunin mo yung homogeneous. So, equal lang yung homogeneous doon sa original drive natin doon sa fake drive natin. Okay? Magbabago ngayon yung ano natin, yung ansatz natin for VCP. Okay. So since ganito yung ano natin, ganito yung input natin, yung peking input natin, pwede na tayo mag-assume ng something that is very similar to its form. So I assume na f times e raised to s1 e. Okay? So ginaya ko lang yung ano niya, yung form niya, but with the different variable here. Constant here. Okay? Hindi variable, constant. Okay. Now let's plug in this equation doon sa differential equation. So let's do that. Vi must be equal to Vc plus Rc dVc over dt. Ito yung differential equation natin para lang may guide tayo. Tapos let's plug in kung ano yung mga meron tayo. Vi e raised to s1t. Tapos f e raised to s1t plus rc. Derivative ng itong bagay na to, bababa lang yung s1. Magkakaroon ng extra factor s1. Tapos same function pa rin. Okay. Evidently, magka-cancel yung exponentials. Tama. So, dali, di ba? And makikita nyo, ito na yung lalabas. RC, S1, F. Okay, na-cancel yung mga exponential. Therefore, easily I can find F to be VI divided by 1 plus RC S1. Okay? I have now my particular solution. Okay, at this point, sir, bakit natin pinipilit tong fake drive natin? So kapag nag-assume tayo ng ganitong drive, pwede natin expand yung exponential, di ba, into these two terms. Okay? So sum siya ng dalawang terms para siyang dalawang source. Okay? So ito yan. So dinrawing ulit natin yung circuit natin with the fake drive. So sum lang siya ng cosine and sine. With yung sign natin may imaginary number. Tapos yung ma-measure natin na VCP here is may tilde. Itong part na to. Okay? Now, if I turn off this voltage source here, babalik tayo doon sa original equation natin. So, ibig sabihin, to do that, yung VCP natin is just yung real part yung fake na response natin. Okay? Yung response natin due to the fake drive. Kunin mo yung real part. So, ito yung real part. And you're back to the original problem. Okay? Okay. So, the solution, let's just write things down. So, yung VCPI equals sa F. Ano yung F natin? 1 over 1 plus J omega 1 RC. Okay? Times E raised to J omega 1 E. Okay? So, ito yung kanina, di ba? F is equal, F times E raised to S1T. Tapos yung F natin, na-solve na natin. Okay, may VI pa pala. Sorry. Okay, pinalitan ko na yung mga S, no? S1. Para apparent sa atin na may omega dyan. Okay. Now, ang gusto natin ay ilipat tong bagay natin into a form that is familiar to us, which is Kasi gusto natin kunin yung real part, di ba? Paano natin kunin yung real part nito? Parang gulo-gulo. So, kapag nasulat natin yung complex number na yan into something that's a plus jb, okay? So, in general, we can write complex numbers as this. Then, yung real part nito, real part, is just a. Okay? Di ba? Ang dali. Pag nasulat na natin siya in terms of like this, easier. Di ba? Mas dali. Okay? Or consequently, pwede rin natin isulat in polar form. Yung polar form ay r e raised to I theta. Okay? Tapos, kung kukunin natin yung real part nito, this is just r cosine theta. Okay? Okay, kasi si e raised to I theta, di ba, pwede mo siya isulat as cosine theta plus I sine theta. Okay, so two terms na yun, tas kamukha niya to. Okay? Therefore, pag nasulat mo siya as ganyan, pwede rin tong part na to. Okay? Ano yung r sa bagay na to? Yung r ay square root ng a plus b. A squared plus b squared. Okay? Tapos, yung theta would just be inverse ng b over a. Okay? Okay, parang ano lang to, parang xy coordinates. X to, ito yung y. Ito yung tangkad niya. Tapos ito yung haba. So, di ba tangent theta? Alam natin siya na opposite over adjacent. Opposite over adjacent. So, yung opposite yung tangkad, tapos yung adjacent yung length. So, y over x, b over a. Okay? Ito ay Pythagorean theorem lang. Kung a-assume mo na x ito ay y, that's y ito. Alright, anyway. So, ayan, may choice tayong ganyan. So, from here, we can break down itong exponential into something like this. Or transform natin to such that magiging exponential siya. Okay, so gagawin ko yung latter. Gagawin ko itong exponential or polar form sa formal term niya. Okay, first things first, gawin natin apparent yung itsura niya. Okay, multiply ako ng 1 minus j omega 1 RC 1 minus j omega 1 RC. Okay? So, nag-multiply lang ako ng 1. So, this is just 1, di ba? Magka-cancel lang. Pero, useful yan kasi malilipat natin sa numerator yung imaginary number. Okay, so yung denominator would be simply 1 plus j omega 1 RC. So, slowly. 1 RC. Tapos yung negative j squared. So, that's positive. Omega 1 RC squared. Okay? Tapos, the numerator is as is. Cancel to. Now, I have something that's familiar to us. So, VI. Isolate ko lang yung mga constants na lang, yung mga real constants. Okay? So, real constants lahat to. Tapos, meron akong, ayun, nakikita nyo na yung form niya. J omega 1 RC. Okay? Tapos, e raised to J omega. Okay? So, pwede ko ito i-transform. Sabi ko nga, pwede ko siya i-transform into this. Okay? Hindi pa ba tayo tapos dito? Hindi pa, no? Kasi dalawa yung J, dalawa yung imaginary numbers. So, kailangan isang imaginary numbers lang. Isang imaginary number lang. Kailangan isang ganto lang or isang ganto lang. So, hindi pwedeng combination kasi magulo yun. Okay? So, lilipat ko rin to sa exponential para pwede ko na pagsamahin yung dalawang exponential. Mas madali. So, by the formula, 1 plus omega 1 RC, papihin ko lang. This one, so magiging RE raised to I theta, di ba? So, yung R ko would be square root ng 1 squared plus B squared. So, ito yung B. Ito yung B, no? Omega 1 RC na negative. Tapos, square doon, mawawala lang din yung negative sign. I have this. Okay. Then, yung E raised to I theta. Tawagin ko na lang siyang phi para cute. Okay. So, then E raised to I, J. J pala tayo, sorry. Omega 1 pala to. Okay. Omega 1. Okay. Okay. Now, si phi I, sabihin lang natin dito, phi I, hindi na natin siya explicitly sulat doon para hindi nagkakagulo-gulo buhay natin. So, yung B ko for this case is negative omega 1 RC. Negative omega 1 RC divided by yung X would be, or yung A would be 1. Okay? So, ayan. Now, pwede ko pagsamahin tong ano, no? Itong factor na to, tsaka ito. This becomes the square root. Di ba pwede ako mag-multiply ng square root of this? Multiply ako ng 1 dito with this amount para lumipat sa denominator. Nagets ba kung paano to? Thumbs up naman. Thumbs up kayo kung nagets niyo. Yung pag-simplify nito to this part. Isa lang yung naka-thumbs up. Sige, slowly. So, V I 1 plus omega 1 RC. Sige, slowly tayo. Multiply ako ng 1 lang. Okay, multiply ako ng 1. So, this is 1. Di ba magka-cancel lang to? Pero, it's helpful kasi pag minultiply ko to, itong dalawa, magka-cancel na to. Magka-cancel to dito. Di ba? Kasi mawawala yung square root. Mawawala yung square root na itong dalawa. Pag pinagsama mo sila, tapos ito na yun. Ka-cancel na sila. So, cancel na natin. Tapos, yung exponential terms, I could join them into 1. Omega 1 plus p. Okay? Therefore, yung VCP ko, VCP is equal to the real part ng VCP tilde. Okay? And yung VCP tilde natin is in the form of exponential. Exponential tayo. So, cosine, whatever this is. Okay? So, VI 1 plus omega 1 RC squared. Okay? Tapos, cosine omega 1 t plus phi. And then, yung phi ay ito. Sir, paano po ulit naging square root of 1 plus... Okay, so itong part. Itong part na to, ito ba yung tanong mo? Ito yung part na to napunta dito. Okay, so may tanong tayo, paano raw ito napunta dito? Okay? Okay, so kapag meron tayong complex number na A plus IB, so ito yung form. Kapag meron kang in general, meron kang form na A plus IB. In our case, yung A natin would be 1 plus J omega, negative omega 1 RC. Okay? So ito yung A mo, ito yung B. Yan, di ba? Pwede mo siyang ilipat sa polar form. Ilipat mo sa polar form, magiging RE raised to J theta. Okay? So magiging, pwede mo siya ilipat sa RE raised to J theta. Okay? So yung R would be, ang formula niya would be this. A squared plus B squared. So 1 squared plus this squared. Kaya siya naging ganito. 1 squared plus omega 1 RC squared. Yun siya. Okay, so that's yung R. And then yung theta would be tangent inverse or tangent ng B over A. And tinawag na lang natin siyang phi. Dito in this part para cute. So yung phi usually siyang ginagamit as phase factor para magka-letter sila. No? And then that's just B over A. And yung B ko, in this case, ay negative omega 1 RC. Negative omega 1 RC over 1. Which is yung A. So ito. Ito yung transformation na kinailangan to do that part. Nakuha ba? Nalinawan ba? Okay, sige. Very good. Sige. Okay. So, review lang ng ano yan, ng complex numbers. Kung medyo ano na, nakalimot na sa complex numbers, okay lang yan. Maaaral nyo din yan. Okay, so therefore, this is our VCP. Ito na. So, hindi natin sasaksak dito si phi, no? Alam naman natin siya na ganun siya. So, the complete solution is now. Yung VC would be A e raised to negative t over RC. Ito yung kanina yung homogeneous part natin. Tapos yung solution natin for the VCP would be V I over square root ng 1 plus omega 1 RC squared nito. Tapos cosine omega 1 t plus phi, where phi is just arctangent ng negative omega 1 RC. Okay? Okay. So, yun yun. So, kung binigyan tayo ng initial condition, pa-plug in mo kung anong oras yung nangyari yung initial condition, tapos mahanap mo si A. Okay? So, that's the complete solution. Alright. For most cases, yung circuits natin, bukas siya for a long time. Hindi siya sudden on and off lang. Okay. So, mahalaga sa atin would be yung steady state response. Okay? Steady state response. Ibig sabihin, again, ng steady state response is that kapag yung T mo nag-approach na to infinity. So, matagal nang nakasaksak yung mga elements mo to a voltage source or to a source. Okay? And then here, kung hihimayin natin, sinusoidal steady state response, ibig sabihin lang yung response ng circuit at T is equal to approaches infinity. Tapos sinusoidal dapat yung source. Okay? So for our case, kung ito yung complete solution natin and important lang sa atin yung steady state response niya, ibig sabihin nakabukas na yung circuit for a very long time, i-approach lang natin yung mga T natin dito to infinity. Okay? So this term vanishes. This term vanishes. And yung matitira na lang would be the cosine term. Okay? Kasi wala naman sense na t is equal to infinity sa cosine. Kasi yung cosine just sumasayo-sayo lang siya from negative 1 to 1. Okay? So this is your steady state response. Sinusoidal steady state response. Okay. So yung steady state response, tinatawag siya kunyari for a cosine. Shorthand term is response to a cosine. Okay? Response to a cosine source. Okay? However, if we are talking about the complete response, okay? So a complete response would be this, the complete solution. Tawag natin would be response to a cosine burst. Okay? Kasi yung source natin ay cosine burst. Lang. Terminologies lang. Okay. Okay. Some observations lang. Yung ano natin, yung for us sinusoidal steady state response, yung voltage natin sa capacitor is just yung particular solution natin. And in a more specific manner, yung real part lang nung particular solution yung kinukuha natin in response to a yung fake drive natin. Okay? So ito. And then yung in a more explicit manner, yung VCI, so yung first term yung nandito ay yung magnitude ng VC, tapos cosine omega 1t, tapos yung argument ng VC. Okay? Kasi si VC ay generally complex number. Okay? So yung magnitude, kinuha natin yun. Yung magnitude ay itong part. Plus the, times the other terms. Okay? So ito yung part na yun. Tapos yung argument or the angle of VC is just this. Yung phi natin. Okay? Which is this. Okay. So wala lang observations lang. In general, pwede natin sa sulat agad ganito. Yung result mo sa RC circuit. And then, looking back, sa part na sinolve natin yung VC. So, yung sinolve natin kay VC, saan part yan? This part, okay? Nagbigay tayo ng ansatz for the particular solution, which is an exponential. Then, sinolve natin siya. So, yung VC natin, VCP, or VC in that case, no, is etong part na to. So, balik natin. Okay. May something familiar dito. Pag nagmamath na kayo lagi, no? Pag solve kayo ng mga problem, sometimes may mga things na nagiging familiar itsura. Okay? So, let me just break this down into something like this. 1 plus RC. Expand ko na S1, which is just J omega 1. Okay, and then let me bundle up this whole thing. Okay, let me bundle up that whole thing as that. Pagsamasamahin ko sila, no? Tapos, factor out ko CJ omega 1. So, that's 1 over CJ omega 1. Bothered lang ako sa positioning. Sorry. Lusog ko lang. Gusto ko na una yung imaginary number. Arte lang. Okay. Yan. Tapos VI. And then, I could lipat ko to sa numerator. So, I have VI. It would look like this. J omega C. Familiar ba sa inyo yung itsura ng mga ganitong equation? Meron kang voltage sa kaliwa, tapos yung voltage ka dito, tapos may ganitong equation. Sulat pa natin to ng, tawagin natin siya R prime. So, V, C, plus VI, tapos tawagin natin R prime, plus R. Di ba voltage divider lang to? Kung may VI ka, tapos may resistor ka dito, meron kang unknown element there with R1. So, kukunin mo yung voltage dito, VC, kunyari. This is just VI, voltage divider lang. So, yung katabi mo, so R1, tapos yung total in series. Okay. So, very nice. So, with that, let's introduce the impedance. Okay? So, impedance, yung mga capacitor natin, pwede na natin siya isulat as some element with impedance. With these impedances. Okay, so yung impedance ng resistor is as is, same lang, R pa rin. Yung impedance ng capacitor would be 1 over J omega C. And then yung impedance ng inductor would be J omega L. Okay? Tapos, yung capacitor mo, drawing mo na siya as ganito. Okay? Tapos yung inductor, drawing mo na siya as ganito. Okay? Aesthetically, mas madali, no? Tsaka, feel ko mas maganda, mas aesthetically pleasing siya. Kaysa drawing ka ng spaghetti. Mahirap kaya ng inductor. O, di ba? Pangit. Okay. Pangit nung pag dinodrawing mo siya. Mahirap. So, mas maganda box na lang. Okay. And then, in general, V is equal to IZ. The voltage across is just equal to the current times the impedance. Okay. So, yung resistor, kung may resistance, na kabaliktaran niya would be conductance, di ba? Kung naalala niyo pa yung conductance sa ohms, siya yung legit na nasa ohms law, di ba? Yung J is equal to sigma A sa 130. Tapos, yung syempre yung impedance, naroon din siyang kabaliktaran. Admittance yung pangalan mo. Okay. Wala lang. Terminologies again. Okay. So, with this, ano pa ba? Kung papansin ninyo, kung ipa-plot natin yung mga impedances with respect to the frequency omega. Okay? So, Z with respect to omega. Papansin mo si omega L, syempre linear lang siya. Linear. Tapos si resistor would be a constant. Di ba? Kasi constant lang siya. Tapos yung 1 over J omega C would be 1 over omega. Okay. Ano mahihinuha natin dito? So at low frequencies, yung inductor mo, para siyang wire. Kasi almost zero yung ano niya. Well, nagzi-zero out minsan yung impedance niya. So it just allows current. So para siyang short circuit. Short circuit for low frequencies. Okay? And then open circuit kapag sobrang laki ng frequency mo. Kasi tataas na masyado yung impedance. Okay? Pag mataas yung impedance, parang mataas na resistance, di ba? So walang dumadaloy na current. So magiging open circuit sila. Capacitors, kabaliktaran. Open circuit kapag mababa yung frequency. Kasi mataas dito yung niya. At omega approaching 0, magiging infinite yung impedance mo. Okay? Then bumababa yung impedance kapag omega approaches infinity. Okay. So, the nice thing about impedances, no? Yung pagsasama-sama nila kapag naka-series and parallel, kaparehas na ng resistor. Okay, so series na Z in series. So Z effective, it's just Z1 plus Z2 plus Z3 and so on. And then Z in parallel would be katulad nung ganito. Kahit ano siya, kahit anong impedance yan, kahit inductor, kahit capacitor, it would follow this relationships. Okay? Okay. So, writing standard lang natin. Siyempre kapag capital parehas, ito yung mga DC voltages, kung naalala niyo pa. Tapos kapag total variables, ito, small then big. Tapos kapag small signals or noises, small parehas. And then kapag complex, capital then small. Okay. So with impedance, yung mga tawag dito, yung mga capacitor and inductors natin, pwede natin siyang gawing impedances. Then pwede mo na siyang pagsamasamahin like Thevenin. Pwede mo na natin gamitin lahat ng pinagagamit natin as before. Okay? Okay. So again, assuming na sinusoidal yung input, tapos steady state response yung tinitingnan. Okay? So kapag hindi ganun, hindi pwede. Okay? So now, in general, we have these few steps. Okay? So una mong gagawin, palitan mo yung sinusoidal sources mo ng complex amplitude. So kunyari, meron kang VA, na VA cosine omega t. Papalitan mo na lang siya nito. Ito na lang. Okay. Then, papalitan mo na circuit elements mo by the impedances. So R, tapos yung omega L, then yung J omega L pala, sorry. And yung 1 over J omega C for the capacitors. Tapos A na yung impedance model ng network mo, yung circuit mo. Okay. And then, ayan, pwede ka na mag-proceed dun sa mga alam mo methods, which is yung node method, Thevenin. Siyempre, Thevenin mo para madali na buhay mo, di ba? Para RL and RC na lang sila in the end. Ayan. So, and then lastly, pwede mong kunin yung time variables, yung response niya, steady state response. Okay, pero kasi kaya number 4 not necessary. Sinasabi niyo to kasi mas mahalaga yung frequency response na makikita natin later on. Yung kung paano nag-work yung circuit mo in terms of its frequencies. Okay, and then ayun yung output mo for an output VO. So syempre, kunin mo lang yung magnitude, tapos cosine, tapos yung argument, yung angle. Itong complex na to, yung complex variable na to. Okay, let's have an example. Series RL. So assuming that we have this input na cosine. Tapos titingnan natin ngayon yung voltage sa resistor. Okay? Voltage sa resistor. So, ang gagawin mo, redraw the circuit. So, yung VI, papalitan mo nung amplitude ng wave. So, magiging ganyan na lang siya. Then, palitan mo ng boxes yung elements mo. Okay? LS, then R. Okay, and then proceed with the voltage divider. Tapos ka na dito. So, say R divided by the total. Tapos VI. Di ba? Simple. Then plug in the things that you know. R, tapos J omega 1 L. So yung omega ay nakadepende doon sa input. Okay, na-solve mo na. Solve mo na yan. Kukunin mo na lang yung angle nito, yung magnitude nito. Ilipat mo siya sa A plus IB. Okay? Tapos makuha mo yung magnitude as yung VI times yung square root na A squared plus B squared. Okay? And then, yung C would be tangent inverse ng P over A. Okay, di ba? Dali lang. Tapos malilipat mo siya sa ganitong form later on. Okay, hindi natin solve yun. Okay. Okay, titignan ko lang notes to. Okay, ito yung sinasabi kong frequency response. So yung mahalaga sa mga ganitong circuit is the frequency response. Okay, so yung frequency response is a plot of the magnitude and phase. Okay, so dalawang plot sila. Magnitude versus frequency, and then phase versus frequency. So dalawang plots sila. Dalawa yung frequency response. Okay? And then yung transfer function is just the output over input. Okay? So, complex amplitude ng output, complex amplitude ng input. I-divide mo lang sila. Okay. So, feel ko mas madali kapag example yung binigay natin, syempre. Okay. So, for tingnan natin yung resistor. So, yung resistor, meron siyang transfer function na H. So, lahat ng transfer function H yung tawag natin sa kanila. Okay. So, just gagawin mo lang, divide mo lang yung complex amplitude ng voltage saka yung complex amplitude ng current. Okay. For this case, ayan siya. So, ito yung transfer functions mo. So, R for the, pinaplot lang natin sa resistor and sa mga elements lang natin. Titingnan lang natin itsura nila. Definitely, ganito lang itsura nila. Okay? And then, kapag kinuha natin yung yung magnitudes, di ba yung magnitudes ay a squared plus b squared. Okay? So for this part, wala namang imaginary number. So b is equal to 0. Tapos yung a mo is just r. So r squared, the square root, r lang yon. And then for the inductor, ito ay omega L. Tapos walang real part. So omega L squared. Tapos yung square root mo. So yun lang din matitira. Tapos capacitor, similar way lang. Yun na lang matitira. Okay, paano nakuha yung mga angles? So, ganun lang din. Tangent inverse ng B over A. Okay? So, sa resistor natin, 0 yung B kasi walang imaginary number. So, arctangent ng 0 is just 0. Yung phase delay. Okay, and then yung for the inductor naman natin, yung numerator would be omega L over, walang real part, so 0. So, tangent inverse ng infinity would be 90 degrees. And then, for this part, sa capacitor naman, ito ay ililipat natin sa numerator yung J, no? Pag nilipat natin yun, magiging negative. Or formally, pwede mo multiply ng J over J. Okay? So, J over J, multiply ka, that's just 1. So, yung numerator J na. Tapos, J times J, negative 1 omega C. So, this is just negative J omega C. Okay? So, yung tangent inverse or tangent would be negative omega C. Yan, negative 1 over omega C divided by 0. Kasi wala pa rin real part. So, infinity pa rin. Kaso nga lang negative, so that's negative 90 degrees. Okay, and then pag pinlot mo to, di ba madali lang naman siya i-plot with respect to the omega. Okay, omega. So, frequency, yung omega mo, radians siya kasi omega. And then, ayan, since constant yung resistor, constant lang siya dapat. And then, yung omega L linear in terms of omega. And then, this one is 1 over omega na plot. Okay. Ang problema dito sa plotting na to is that yung L and R, L and C are very small. Di ba lagi silang nasa micro, nano, and pico na scale. So, ang hirap na nandito lagi yung mga bagay-bagay. Kailangan pa i-scale yung graph mo para makita yung important values or important things here. So, maganda, pwede natin siya ilipat sa logarithmic scale. So, kapag ginawa mo yun, so, kunin mo lang yung mga logarithm ng mga bagay-bagay. So, ito ay feel ko mas okay na to. Tapos, itong part na to ay log 1 minus log omega c. 0. So, negative log omega c. Tapos, ipa-plot mo ngayon sila sa logarithm scale. Ito na yung magiging itsura nila. So, kapag ang gagawin mo lang para ma-plot sila ay titingnan mo yung mga nasa loob. So, omega L. So, in terms of omega, magiging linear na siya sa logarithm scale. So, yung omega L, ito na siya. Yung slope niya ay yung L. Okay? Tapos, for the The other one, sa capacitor, since negative, pabaliktad yung slope. Negative C yung slope. Tapos ayan, kasi nakaplot sila sa logarithm scale. Okay, paano magbasa ng logarithm scale? Ito ay yung mga susunod na mga increments. So that's just 20 raised to 4, 30 raised to 4, 40 raised to 4, 50 raised to 4. Ito yun. Itong paliit. 60 raised to 4, 70 raised to 4, 80 raised to 4, 90 raised to 4. Then, syempre 100 raised to 4 is just 10 raised to 5. Okay? So, yun yung maliliit na yun. Ito siya. Okay? So, syempre parang magulo pa siya ngayon. Try natin with an example. Para tayo naguguluhan. Okay. So, mag-sketch tayo ng frequency response. I-sketch natin yung circuit natin kanina, yung RL. RL. Itong part na to. Sketch natin to. Try natin to. The frequency response. So, ito yun. Ito yung ito yung voltage divider equation mo dun. Tapos, kunin mo yung transfer function. Divide mo lang yung output and input. So, this one and this one. VO over VI. So, you have this part. Okay? And a more illuminating way of writing this is i-factor out mo yung L. Okay, factor out mo yung L both sides. And you end up with this equation. Okay. So may transfer function ka na. And you want this to, you want this equation to be plotted with respect to the frequency, J omega. Okay? Okay. So to do that, gawin mo, para makapag-sketch ka ng ganyan, is ilagay mo sa mga extremes yung omega mo. Okay? So assume mo na omega, lipat mo papunta sa 0, then omega to infinity. Makikita mo yung mga response ng transfer function. Okay? Okay. Okay, sige. Gamitin natin to. So R over L plus J omega. Okay. Kapag maliit yung frequency, omega approaches 0. So magulalaho lang to. Ma-overwhelm siya nung term na to. Diba? So yung denominator would just be R over L. And R over L divided by R over L is just 1. Okay? So yung magnitude ng transfer function mo when near 0, C omega, ay 1. Okay, next naman, infinity. So, lagay pala natin para hindi magulo. Okay, so this is just 1. And then, kapag ginawa mo naman infinity, mado-drown out nung J omega yung RL. So, ito na lang yung matitira. J omega. Or, in a much illuminating term, 1 over L over R, J omega. Okay. So, with these values, pwede natin siya i-plot. Pag ito yung pinili natin value, 10 raised to 6 yung R over L. Okay. So, may silbi tong R over L. Okay. So, kapag omega is equal to R over L, magka-cancel sila, di ba? So, important yung part na yun. Kasi dun mo malalaman yung tinatawag nating break frequency or corner frequency. Okay, so kailangan natin yun para mas magadali yung graph natin. Okay? So, at that frequency, yung break frequency or R over L, or kung saan equal tong dalawa, no? Magiging 1 din to. Doon yung break frequency. Okay, so i-plot mo yung break frequency, which is just 10 raised to 6. So, lagay ka ng ganon dito. Okay, so punta ka sa unang nakuha mong result, which is yung malapit sa 0. Nakita mo, linear siya na 1. Okay, so 1, linear. Then yung kabila, ang nakuha mo ay 1 over omega. And kapag pinlot mo yung 1 over omega sa logarithm plot, pag ganun lang siya. Okay, pag ganyan lang siya. Hindi na siya pag ganun. Kasi di ba sa linear plot, ganito siya. Kapag 1 over omega. Kapag sa log scale, 1 over omega ay straight line lang na pababa. Okay? Tapos yung slope niya ay ito, R over L. Okay? And then sa break frequency, doon ka magkukurba. Ano lang naman to? Approximate sketch lang. Pero kung gusto mo, pwede ka pang gumamit nito. Gamitin mo yung legit mong equation, no? Yan, yung magnitude. Pwede mo i-plug in yung omega is equal to R over L. And when you do that, plug in mo lang siya. 10 raised to 6 yung R over L natin. Plug in mo siya dyan. Kunin mo yung magnitude, you get this. Okay, 0.7. So around, 1, 2, 3, 4, 5, 6, 7. So, andito siya. Okay? So again, this is 0.2, 0.3, 0.4. Makikita ba? May maliliit na mga tuldok. May maliliit na tuldok. Tapos hindi sila equally spaced dahil logarithm scale ito. Okay. So, ayun. So, next naman na problem natin is getting the this is just the magnitude of the transfer function, di ba? Kunin natin yung phase. So, yung phase naman is yung angle. So, gamitin pa rin natin to. This one. So, R over L. So, without transforming things, pwede ka nang rumekta sa mga bagay-bagay. Okay. So, kapag kinuha natin yung omega approaching 0, this becomes 1. Okay. Kapag omega approaching infinity, this becomes R over L j omega. Okay? Okay, anong point ay pag naging ganito na siya, ano yung real number na lang to, di ba? So yung tangent inverse, it's just 0. Tangent inverse 0, and that is 0. Okay? So for low frequency, 0 siya. And then this part, so this is just negative j. Nilipat ko sa taas, no? Omega. So kung kukunin natin yung tangent inverse niya, problema ay yung wala siyang real part kasi puro imaginary number lang to. So this is just R over L, omega, negative. Pero negative infinity to. So that's just negative 90 degrees. So you have those two bounds na 0 and negative 90. Okay? So pwede ka mag-plot ng ng logarithm scale yung x, tapos yung y ay in linear scale. Pwede yan. Wala kang problema. So when you do that, ito yung kalalabasan niya. Okay, so kuha ka ng asymptote na 90, kuha ka ng asymptote na 0, then smooth graph lang siya. Tapos, ang mahalaga pala dito is yung break frequency, nangyayari siya sa 45 degrees. Okay? Break frequency sa 45 degrees. So, applicable lang to kapag yung mga transfer function mo is of the form na ganito. So, 1 over s plus some constant a, s plus a, tapos s over s plus a, then s plus a over s. Kasi dito ka makakapag-approximate ng s to s approaching 0 tsaka s to infinity. So mahirap kapag meron ng mga squared and tawag dito, cube. Okay. So another example. Ito. So this is just s over s plus a. So s over s plus a. So yan siya. Then as usual, tingnan mo lang yung response niya when you go to 0 and when you go to infinity. So when you go to 0, mag-drown out to, matatanggal to nasa denominator, 2,000 na lang yung magiging nasa denominator. So omega over 2,000 kung yung magnitude lang. Okay, and then kapag malaki naman yung omega, so ma-drown out yung 2,000, so j omega over j omega, that's just 1. Okay, and then yung breaking frequency, yung break corner frequency, it's just 2,000. Kailan siya magiging 1. Okay, therefore, from that, pwede ka na mag-plot nung magnitude ng transfer function mo. So, yung first part, yung malapit sa omega is equal to 0, linear siya. Kasi logarithm scale, linear, and then magiging 1. Tapos, kung nasaan yung curve, nasaan yung break or corner frequency, 2,000. So, that's 2 raised to negative 2 raised to 3. Okay, so dito yun, sa part na yun. 2 raised to 3. Okay, so yan. Next naman is yung angle. Kung titignan mo dito, approach natin to 0, di ba? So matitira ay j omega over 2,000. So kapag kinuha mo yung angle nito, infinity siya na positive. Okay? Positive infinity. Kasi walang real term. Okay, next is kapag nasa dulo na, 1 na lang siya, omega approaching infinity. So ito ay tangent inverse ng 0. 0 degrees. Okay, so yan siya. So again, yung break frequency, dun yung 45 degrees, tapos 90 sa una, 0 sa dulo. Okay? So, smooth curve lang na ganun. Okay, kung papansinin nyo, yung transfer function is the, H is output over input. Diba? So, kapag mababa dito, ibig sabihin, mas mababa yung output kaysa sa input, kaya siya nag-zero out. Okay? Kapag dating dito sa 1, ibig sabihin pantay na yung output sa input. Okay? So, nasa maximum output ka na, which is katulad, which is yung input. Okay? Mahirap naman mag-output ng mas malaki sa ini-input, no? So, hindi pwede. Okay, kung mapapansin nyo, at low frequencies, mahina yung output mo. Okay? At low frequencies, mahina yung output mo. Kapag high frequency ka, mataas yung output mo. Okay? So, itong mga ganitong circuit, kaya natin siya tinitignan yung frequency response niya kasi makikita mo na may filtering na nagaganap. Okay? So, allowed dito, malakas yung mga low frequencies mo. Tapos dito naman, mahina yung mga high frequencies mo. So, ang tawag dito sa ganitong circuit is a low-pass filter. Low-pass meaning nagpapass yung low frequencies. Tapos sa kabila naman, ito ay high-pass filter. Kasi nagpapass yung mga high frequency. Tapos binablock out niya yung low frequencies. Okay? Very useful to sa electronics, lalo na sa mga imaging, ganyan. So how would you know that alin yung mga signal, alin yung mga noise? So kailangan mo ng filters. So yun nga, ayan. Ito yung mga filters natin. So meron na low pass, inaalaw mo yung mga mabababang frequency. Tapos high pass, inaalaw mo yung mga high frequency. Band pass, ibig sabihin, may inaalaw ka ng certain set of frequencies. And band stop, may pinipigil lang ka na certain set ng frequencies. Okay, kunyari may sige, ito na lang. Tuloy natin yung example natin. Okay, suppose meron sa inyo na gustong gumawa ng stereo, no? ng amplifier ng sounds. Okay, so stereo. Okay. So gusto mo ang gawin mo ay ma-separate mo yung mga high frequency sa low frequency. Okay, so meron kang ganitong itsura ng schematic. Okay, so meron kang CD player, may output yan. Tapos ipapasa mo ngayon sa isang network mo na magdi-dismantle ng high frequencies and low frequencies. Okay? So, syempre, i-amplify mo yun para malakas siya sa speaker, syempre. And then, ayan. Tinatawag mo siyang tweeter kasi high frequencies lang yung kaya niya i-produce. And then, sa kabila naman yung woofer mo, siya yung mga low frequency sounds, di ba? Okay. Gusto mo tong gawin kasi gusto mo maganda yung bass, no? Tsaka yung treble ng mga papatugtugin mo para satisfying siya. Okay? Ngayon, nag-aral ka ng 180, tapos nalaman mo na magagawa mo to by just doing an RL circuit. Okay? So, RL circuit. However, you have a problem. Hindi mo alam kung kanino yung woofer, kanino yung tweeter. Kanino mo ikakabit? Kay inductor ba or kay resistor? Okay. So, now you solve for the problem. Okay? You assume that yung signals ay is a sinusoid. Okay? Kasi any waveform naman, sabi nga ni Fourier, pwede mong isulat as sums of sinusoids. Okay? So, therefore, valid ka lumipat sa impedance model. Okay. So, now you have this impedance model. Then, you solve for the voltages. Okay? Ngayon, some problem lang. Baliktad yung mga bagay-bagay. Di ba usual kasi ganito yung ginagawa natin? Plus, minus. Plus, minus. Diba? Ganito yung ginagawa natin usually. Pero this time, baliktad. Okay? So, to solve this, solve muna natin yung normal. V, tapos, ito ay L, LS, R. Okay. So, for VL ko ay VI over, VI ba yung gamit? Okay, VI times yung voltage divider. Okay? However, baliktad yung VI ko, so babaliktarin ko lang. Negative. Okay? And in a similar way, solve nyo na lang, VR is just negative R negative VI R over LS plus R. Okay, voltage divider lang din naman. Okay, so yan, we have this kind of equation. So may transfer function ka na ganito. Okay, so LS lang ito. In-expand lang si S as J omega. So VL over VI, you have this transfer function. Then VR over VI, you have this. Okay, syempre tapos, alam mo na gagawin mo. I-zero out mo yung mga omega at saka papalakihin mo yung mga omega to infinity. Okay, so breakdown natin. So yung mga una ay yung mga zero yung omega. So approaching zero. Okay, J omega L over R. Tapos at infinity, ang mangyayari ay negative 1. Tapos for the other one, magiging negative 1. Tapos at the end, R over J omega. Okay. So yung magnitudes nito, alam natin that sa VL, pag ganun siya. Tapos sa VR, from 1, tapos babagsak. Okay? So yung sa VR mo, it's actually a low pass filter. Sa VL mo, high pass filter siya. Okay? So yung mga high frequency, yung tweeter mo, sa VL mo ikakabit. Then yung sa VR mo, ikakabit mo yung woofer. Okay? Tama ba yung drawing ko? So VL over VI, ito yun. Ganun siya. Tapos sa VR, pababa. Okay? So sa VR, woofer ito. Tapos, ito ay tweeter. Okay? And then yung kung saan siya babagsak ay yung break frequency mo, which is just R over L. Okay? So now, okay, na-imagine mo na yung theoretical network mo. So you have to build the circuit now. You have to build the crossover network. Pupunta ka ngayon sa Raon, sa Quiapo, para bumili ng mga resistor tsaka inductor. Hindi kaya sa online shopping. Okay? So, kailangan mag-isip na konti ngayon. Yung tenga natin, it can receive here ng 20 up to 20 kilohertz, no? However, healthy. Ito, healthy. Tsaka sa mga bata lang siya na-achieve yung 20 kilohertz. Pag tumatanda tayo, may mga hindi na tayo naririnig ng mga bagay-bagay. Okay. So it would be wise, no, kung healthy pa tayo, no, gawa ka ng cut-off na 10 kilohertz para hati yung bass tsaka hati yung treble. Hati equal sila parts. Pero ayun nga, hindi naman tayo healthy. So pili lang tayo ng sa baba sa 10. So 5 would be okay. Okay. So nagde-design lang tayo. Walang basis to formal basis. So that's the frequency na gusto mo for your the break frequency that you need. And then, since ito ay frequency in terms of hertz, you want it in terms of radians, kasi nasa radians ka. So just multiply 2 pi. And then you have your R over L as 31416.9265 and so on. Okay? So, ayan. Ngayon, pupunta ka na sa raon, pipili ka lang ng values ng R and L such that yung ratio nila, ito lalabas around this. Okay, so nakita ka ng 100 ohm resistor tapos 3.2 millihenries na inductor. Okay, around ano yan, 3, 2. Okay, good enough. So now you have your speaker na naghihiwalay ng bass and treble na sounds. Okay? And with tweaking on your amplifier, pwede mo mas malakas yung bass mo. And then, or kung gusto mo mas malakas yung high frequencies mo, you can do that with your amplifier. So, ayan. Okay. Kuwari, pwede mo rin ito marami pang bagay-bagay na kailangan ng filter. No? Kuwari, gusto mong kumuha ng heart rate. No, heart rate. Heart rate. So, yung heart rate, pwede mo siyang i-measure sa dugo. Di ba? Kapag dumalo yung dugo, mararamdaman mo na may sinusoid na gumagalaw sa mga veins. No? You shine a light, tapos i-measure mo yung nagbo-bounce off na light. Then, you have something that is a waving input of signals. Okay? So, syempre, magbibilang ka lang kung ilan yung bibilang ka lang kung ilan yung peaks. Tapos makikita mo na yung heart rate, divide mo lang by seconds. Okay. However, no? Kapag gumalaw yung tao, ma-disrupt tong wave na to. Nakaroon siya ng pwede siya ma-disrupt with a big signal. Okay? So you want a circuit na mag-filter na such that yung yellow niya lang ay ito. So pansin mo naman na syempre mas mataas yung frequency nito kaysa sa mga movement ng tao. Okay? So usually yung ginagawa sa mga human filters, pinifilter out mo yung movements ng tao. So yung movements ng tao, they are low frequency. So ang gagawin mong filters ay high pass filter. Para kuwari itong heart rate, high frequency to. So yung relativeness ng high and low, no, nakadepende dun sa break frequency. Okay? So wala lang. That's for next time yung mga ganong applications na ng mga bagay-bagay. Okay, and then lastly, tingnan natin yung energy and power, no? Actually, power lang ititingnan natin. Okay. So, kunyari meron tayong circuit na ganito, arbitrary impedance. So, R plus JX. So, yung X usually tinatawag siyang reactance of the element. Okay, so meron siyang resistance R and then reactance X. Okay. In general lang naman to. So, hindi natin alam kung ano to. Arbitrary lang siya. Then, for any sinusoidal source, pwede mo isulat as something like this yung source mo. Okay? So, syempre, kung sine yung source mo, yung phi magiging pi over 2 lang. Okay? Para lumipat siya sa sine. Negative pi over 2. Okay? Okay. Pero hindi pa naman kailangan sa buhay natin yun for now. Sige. So, you have your VI. And then, you can proceed with the impedance model. So, yung current through this part, so dun sa element mo would be just V over Z. Okay? So, VI over Z. Okay? So, paano nakuha tong VI? Sabi nga natin, di ba, pag mag-impedance model tayo, kunin lang natin yung amplitudes. So, yung phi ay kasama sa amplitudes nito. Okay? So, pwede mo ilipat to sa pwede mong mag-fake source ka na VI e raised to J omega t plus phi. Okay, dismantle mo yung wave to J phi tapos J omega t. Okay, so this is the wave, this is the amplitude. So, yan. Ayan siya. Okay? Para lang clear sa atin kung paano nahugot yan. Okay. So, ayan. From this, gusto mo ilipat into a single polar form lang. Kasi nakikita mo dito, numerator mo may polar form, tapos denominator may Cartesian complex number. So, ilipat mo yung Cartesian into polar, nakaroon ko pa ng isang angle, theta, which is just the angle between this complex number. So, tangent inverse ng x over r. Okay? So, yan. So, lahat ng constants na masasama mo, that's your magnitude of current. Okay, now we're ready to proceed with writing this down as yung real part lang. So, yung real part nito would be getting this part, tapos cosine omega t plus yung phase, which is phi minus theta. Phi minus theta. Ayun yung phase niya. Okay, so ganito pa rin yung form. So magnitude, cosine omega t plus phi. So this is for your current. And as usual, power is just voltage times current. So yung voltage niya, syempre, series lang naman sila. Kung anong voltage ng input, ayun din yung voltage dito sa element mo. So multiply those two. You have this. Okay, multiply lang natin sila. And you have this. You could simplify the trigonometric factors into a single ito. Pwede mo siya i-simplify yung trigonometric factors mo. Okay, and then, so ayan, meron kang explicit term for your power. So, syempre, hindi naman to tinitignan ng Meralco. No, hindi naman nila tinitignan kung ano yung na-consume at some certain time t. Kinukuha nila yung na-consume mo, yung average consumption mo. Okay? So, the average, i-average mo tong bagay na to. So, ang mangyayari is that i-average mo yung waves mo, cosine. So, ito lang yung may time dependence. Itong cosine lang na to. So, this is a constant. No? So, anong average ng cosine? Di ba yung cosine mo ay from negative 1 to 1? So, anong average niya? 0. Okay. So, pag in-average mo to, mawawala lang yung cosine. Mawawala lang to. So, you're left with this part. Okay? And in a more general sense, ganito yung ano niya, ganito yung form niya. Pwede rin na ilipat mo sa in terms of complex variables, vi and i. Tapos ganito yung form niya. So yung asterisk ay yung complex conjugate. Okay? So a plus ib, pag kinuha mo yung asterisk nito, ang lalabas ay negative lang yung may mga i. Okay? Okay. So you have those averages power. Maganda tignan na, okay, kuwari yung arbitrary element natin na may r plus jx. So kunyari, pure resistance lang siya. Kung pure resistance lang siya, ibig sabihin yung reactance mo, 0. So therefore, balik tayo dun sa equations natin. Okay, balik tayo dito. Okay? Tapos, actually dito na. Dito tayo bumalik. I-assume natin na yung source natin ay pure cosine. Pure cosine. Ibig sabihin, wala siyang phase factor. 0. And then, reactance natin is 0, di ba? Ibig sabihin, ang consequence na x is equal to 0 ay yung theta mo is just 0 also. Okay? So, ito ay ayan. Ang mangyayari ay mag-0 yung x, mag-0 yung theta. Tapos, ayun, ang matitira dito. So, yung r squared mag-cancel lang with the square root. So, r na lang siya. Tapos, cosine 2 omega t. Wala na yung 2 phi. Wala na rin yung theta. 1 lang ito. So, 1 plus 2 cosine, 1 plus cosine 2 omega t. Tapos sa labas, ito na. So, this is the power, instantaneous power. And kapag kinuha mo yung average nito, again, yung cosine maglalaho lang. So, therefore, you're left with this term. So, VI squared over 2R. And it's nice, no? Kasi ito yung alam nating power na hindi pa pala. Ito yung alam nating power. So, pwede natin tawagin yung RMS, VRMS. So, VRMS is just yung actual amplitude VI divided by the square root of 2. And then kapag ginawa natin yun, so pwede nating i-1 over R. Factor out natin yung VI, yung square. Okay? So, yan yun, di ba? It's just the same. So, yung VI over square root of 2, that's just your RMS, VRMS. Okay? And squared. So, ito yung legit na alam natin. V squared over R. Okay? So, yung VRMS, yung actual computation niya, is just root mean squared. Root average nung square ng instantaneous voltage. Okay. So, yung mga outlet natin, RMS voltage yun. 220 volts. Okay. So, AC kasi yung voltage natin. So, para makakarakterize yung AC voltage, kailangan mo nung VRMS. Pag 220 volt AC, so ibig sabihin RMS voltage yan. So, the actual voltage, kapag sinuksok mo yung daliri mo dyan sa outlet mo, may mararamdaman kang 220 times square root of 2. So, this is around 300 volts. Okay? So, kapag sinuksok mo yung daliri mo, may mararamdaman kang 300 volts. By chance. Kasi nagsa-sinusoid, di ba? In 60 Hertz. So, probably, wala. Hindi ko alam. Huwag niyo i-try. Okay? Okay. Next naman ay, paano kaya pag pure reactance lang? So, ibig sabihin, assume natin na, again, walang pure cosine na naman. Cosine. So, that's phi is equal to 0. Then, tawag dito. Yung theta natin, magiging 90 degrees. Okay, kasi R is 0. So, di ba yung tangent inverse sin theta is just x over R. So, kung 0 yung R, mag-infinity to. So, therefore, 90 degrees. Okay, going back to the expression. So, 0 yung phi. Tapos, meron akong pi over 2 dito. Tapos, cosine pi over 2 is just 0. And then, mawawala yung r ko dito. X na lang ito. So, meron akong vi squared over 2x. Tapos, cosine 2 omega t minus pi over 2. Tapos, may plus 0 ako dito, di ba? Kasi, Ayan. Nag-zero out ito dahil sa pi over 2. Okay? So, minus pi over 2 kasi may minus sign. Okay. Kung mapapansin mo dito, kapag in-average mo to, pag in-average mo to, zero out siya. Okay, paano napunta to dito? Di ba yung cosine, pwede mo siyang isulat as sine kapag meron siyang phase na negative 90 degrees. Cosine theta minus 90 degrees or cosine theta minus pi over 2 para malinaw sa lahat. This is just sine theta. Okay? So, ayan siya. Kaya siya napunta dyan. Tapos pag in-average mo to, anong average ng sine? Yung sine, negative 1 to 1 lang din. 0 lang din. So, yung average power sa isang pure reactance na element, walang dissipate na power. Okay? So, it gains power and releases power at the same time. So, walang nangyayari. Hindi siya nagdi-dissipate. Okay? So, walang loss sa isang pure reactance na element. Okay. So, ayun. Any questions? Any questions? Sana naguluhan. Okay, so ang summary nung ginawa natin, meron kang impedance, meron tayong bagong element is yung impedance natin. Tapos ito yung mahalaga. Ito yung mahalagang kailangan mong gawin. 1, 2, 3, 4. Okay? So, sulat mo lang yung source, magiging voltage na lang siya. Amplitude na lang siya. Tapos impedance, model. Tapos yung standard analysis techniques natin. Tapos, you go back to the time or yung frequency response mo. Okay? So, wala nang tanong.